Go ahead and grab out your worksheet thing I had yesterday. So I'm going to go over the two that you were supposed to do last night really quickly here. And then we'll should have time to do two more. And then you'll have two to review that will help you practice for tomorrow. So in number 3, there is nothing to factor. So the domain is going to be what the denominator can't be, which is all x's such that x cannot be 4. Because if you were to solve this, you would just add the x over and x would be 4. Negative 4 would be a negative.
I subtracted the 4 over.
Yeah, it's kind of tricky.
How do you know you should subtract the number or the?
Well, you don't want a negative x. You always want a positive x. You could also subtract the 4 over and then divide by -1.
Oh, I just forgot that last part.
You just don't want a negative x.
Okay.
All right, you're welcome. And then next is x-intercept. There is no x-intercept because 1 could never be 0. That doesn't make sense. 1 equals 0 doesn't make sense. So there's none. Y-intercept. We plug in 0 for x. So when you plug in 0 there, it just becomes 1 over 4. Y equals 1 over 4. Is everything left over? Then it's just 1 over 4. For our vertical asymptote, 0's of the denominator that are also 0's of the numerators. That's just 4. X equals 4. Horizontal asymptote. Look at the powers. The bigger power is on the bottom, right? So first power, so that's going to be y equals 0. Anytime bigger power is on the bottom, it's just y equals 0. And there's no holes. When everything cancels, no holes. Then plotting this, y-intercept is at 1/4. No x-intercept. Vertical asymptote at x equals 4. Horizontal at y equals 0. So then you need to graph it, and it should look something like this. Yeah. You can use Desmond's help for that part.
So what's the 1/4? You use the first.
Yeah. So that's where it crosses the y-axis.
Crosses.
Yeah. So put it out there at 1/4.
Okay. Oh, all right.
The next one you have to factor. On the top, you want to pull out a -3, and then you're left with x minus 4. You're going to pull out a -3 because you don't want a negative with your x left over. The bottom factors into x minus 4 and x plus 1. So then the x minus 4's cancel. So that's going to tell you there's going to be a hole there. For the domain, we want all x's such that x cannot be whatever makes the denominator 0. So we still need to include this 4 because it does make the denominator 0. And also -1. So those two places where the denominator is 0 or -1. So, sorry, not equal.
So how did you get the x minus 4 instead of the positive 4? Like, what do you do to keep factoring that? Yeah, so like, that's...
So this one, the greatest common factor is a -3. Because 3 goes into 12, so you pull out the 3 and the negative. So the opposite of distributing. So if you were to distribute, you would end up with that. X-intercept, where the denominator is 0. So the only place where it would be 0, looking at this, would be x equals 4. But we said that x equals 4 is a whole. So it can't be an intercept if it's a whole, so we don't want to put that, so there's none. It would be 4, but that's a whole. That means it's undefined there. Alright, y-intercept. Plug in 0 for all the x's. So this is 0, this is 0, this is 0. You just look at what's left over. It's 12 and -4. So y equals 12 over -4, which is -3. For our vertical asymptote, the zeros of the denominator that aren't canceled yet. We just have this one that's left over, so x equals -1. Horizontal asymptote. We'll look at the powers. The bigger is on the bottom again. So it's going to be like with 0 again. And we said there was a hole. There's a hole at x equals 4. So that's all our important information. No x-intercept, we can't plot that. Y equals -3. Vertical velocity of x equals -1. Horizontal at 0. And the hole, which should look like hole there, keep going. And then any questions on those two? All right, let's look at the back. And let's go ahead and tackle the first two. The factoring is actually the most important thing because if you mess up the factoring, then the rest is really hard to get right. So you've got to get the factoring. And then after you factor it, it's really just looking at the factor form and making a decision about what it is. All right, so this one has a -2 in front, right? So we know we're going to pull that out. So you're going to write -2, and then just pull that out of every term. So we have x squared left. With a 4x, what do we write? Yeah, good, -2x, and then -8. And then you can even distribute it back in and make sure it makes sense. -2x squared plus 4 because it's minus, plus 16 because it's minus. So then I'm going to keep this -2 out here and factor the other part, x and x. So we think factors of -8 to add to give us 2. So you're going to be 1 and 8 or 2 and 4, right? So what is it? 1 and 8 or 2 and 4? Yes. It's got to be right to get 2. Gotta have 2 and a 4. And then look at the signs. This tells us it's going to be a negative, so it's opposite. And this tells us the bigger one's negative. So +2 and a -4. Right now at the bottom, factoring. We're thinking what multiplies to give us 4 and adds to give us -5. What two numbers? Yep, it's gotta be 1 and 4 because 2 and 2 you couldn't get 5 of them 2 and 2, right? X to 1, x to 4. The positive tells us they're the same signs, and then this tells us that they're both negative. -1 and -4. Once you get that, then it's just remembering what each of the ones are. Easy to figure out though. So the domain, we want to exclude anything that makes the denominator 0, which are 1 and 4, right? All x is such that x cannot equal 1, 4. We do have a hole, right? Because these are the same. There's a hole there. So when we do our x-intercepts, we're not going to include that 4 because it's a hole. So x-intercepts are the zeros of the numerator. We don't have to worry about that -2 because it doesn't have an x. We got this x plus 2, so that's going to be x equals -2 when we solve it. With a y-intercept, you're going to want to look at the big equation. All of these x's turn to 0, so it's just left with 16 over 4. Vertical asymptotes, you look at the bottom, whatever's left basically in the bottom. So just 1, right? 1's the only left over, 1. Horizontal. Look at the powers. Look at the original one. Powers are the same, right? So ratio of leading coefficients. So that's going to be y equals -2 over 1. And then we did say there was a hole at x equals. So now we graph it. Put all these points on. So x-intercept means we go on the x-axis to -2. Y-intercept means we go on the y-axis to 4. Vertical asymptotes up and down at 1. Horizontals left and right at y equals 2. And I'll go ahead and pull up the decimal back so you can see it. So you can see it there. The 2 points that we found. -2, 0, so that's our x-intercept, and our y-intercept. That y equals 4. 0, 4. And then notice we also said that x equals, was it 3 was undefined? The 3? Where is undefined? Let's see at 3 if I can get there. But where is undefined?
4.
Is it
4.
4?
Okay. 4. Let's see, it changes to undefined there. Very good, you got that spot. Undefined. And it's a little open dot. You can see it as well. So we can see how that connected there. It goes up like this. Goes through those two. And then at 4. And then open dot as well. Once you get the hang of it, the factoring is the hard part, and then it's just basically remembering how you find each of these. So if you need to study how to find all those, do so. All right, which other one do you guys want to do? 6, 7, or 8? 6? Okay. 6. All right, so first thing always is factor it. The top, it can be factored, because notice there's 2 terms that both have an x. So we'll pull out a DCF. This x. Now the bottom has a 2. We want to pull that out, right? All have a 2. X squared plus x minus 6. Basically, we're dividing all of them by 2. So then, put the 2 out here. We'll need a factor, right? We need what? It's going to multiply to give us -6 and add to give you 1. So it's 6. Yep, 3 and 2 will do it. Because 1 and 6, you can't get 1 with 1 and 6. So now it's going to be a 3 and a 2. And we want the bigger one to be positive, plus 3 and minus 3. Now don't just always assume there's going to be a hole and cancel it, because these don't cancel, they don't have the same sign. Don't assume it's a hole. Alright, so now let's go find everything. The main Alexis, so x not equal. And there's 2 spots there. -3 and +2, right? Can't do those. I'll tell you all the things you need to find on the quiz, so if you can't remember all these, I'll tell you. I won't tell you how to find them, but I'll tell you what you need to find. And then x-intercept, so the 0 is the numerator. What are the zeros?
0.
So 3 definitely is. And then this one also we have to take that as well. We set x equals 0, we just get 0. So both of those are x-intercept. It's an x there. And y-intercept. That's where we're plugging in 0 for all the x's. So basically all this gets canceled out. Right? Cover all that up. So what's that going to be? Negative 12 on the bottom. What about the top? Right. So what is it overall? Yeah. If we got nothing left on the top, that's a 0 minus 0, right? On the bottom, we got 0 plus 0 minus 12. 0 over negative 12 will give us 0. So be careful with that. I think downward and asymptotes will make the denominator 0. There was nothing that canceled, so it's just going to be the same as we excluded from our domain there. X equals negative 3 and x 2. Makes that 0. A horizontal. Look at the original one for the horizontal. Their powers. They're the same, right? They're both squares. So it's going to be the ratio of their coefficients. 1 over 2. And there was nothing that canceled, so there's no holes. Alright, let's put this information on the graph here, and then we'll check out the graph. So we have 2x intercepts. 3, 0. We have a y-intercept also at 0, it's going to be the same spot. Vertical asymptote at 2 and negative 3. Horizontal at a half. So this looks a little more complicated than what we've seen before. It's okay that these cross each other. They're not real lines, they're just imaginary lines. So let's look at the graph. So this is what it looks like. It's a little different than the other one we've seen. Let's see if we got all these points. 0, 0, good. And then we said at 3, 0 also. And you can see there's an asymptote here at 2. There's another one here at negative 3. The horizontal one does go here. It's okay that this crosses the horizontal asymptote. It's alright. Because it's just telling us what happens really. So in drawing this, you can take it in pieces if you want to. This part goes here. Then we got our other part that goes up and through. Right. And then our last piece in the corner there. So I know that's a lot in one problem. You'll need to do 2 of these tomorrow. Take it step by step and do it. And these other 2 are homework tonight, 7 and 8. When you turn this in, you put turn in the whole thing. So take a picture of the front and the back, turn it in. These will also help you study for the quiz too. Because you got to do all those steps to get in the quiz, and having problems to practice is really the best way to practice. So, do your best on those. Hopefully get them. I guess number 8 real quick. Just a second here. Anybody know how to, well, think about we're going to have a factor this. Don't say how loud. Think about how you factor x squared minus 1. It's called a difference of squares. It's very similar to, let's just scroll. Do we have one? I guess it was in the quizzes game. Mm-hmm. Remember we had x squared minus 4 in the quizzes? How would this factor? Yeah?
X squared plus pretty much 0 x minus 1.
Well, yeah, so then factoring it would be what?
Right.
Plus 1. Because the 2 terms cancel in the middle, right? There's like no x's. So it's like a positive x and a negative x could be 0 x's. So that's what a box factor.